again to yet another session where we talk about that old subject known as mathematics. Now, in the previous episode, we'll be talking about fractions. We've talked about fraction as it deals with conversion from decimal to fraction and vice versa. We've also talked about the greatness of fraction when we talked about the ascending order and descending order using the symbols or the um, mathematical functions greater than and less than symbols. We also talked about the addition and subtraction of fractions. Today, we'll be talking about the multiplication and division of fraction. Multiplication and division of fractions. Let's get started. First of all, let's see the objective today. At the end of this lesson, you should be able to know about multiplication and fraction in at least the basic ideas concerning multiplication and addition and division of fraction. Then you also know more about the extensive knowledge that has to do with multiplication of fractions as well as the division of fractions. Now let's see what multiplication and division of fraction is all about. Now, to multiply fractions, all you have to do is multiply the numerators against the denominators and simplify the results. That's all. Not much of a big deal. Not much to do. Just whoever is upstairs, multiply the both of them against or divided by those downstairs. And then you simplify your results and you get your final answer. What do I mean? Say for example, I have 2 over 3 times 4 over 5. What the statement there is telling me is everybody at the numerator level, I call them the upstairs, you multiply them, and then everybody at the denominator level, I call them the downstairs, you multiply them. So 2 times 3, 2 times 4 rather, is 8, and 3 times 5 is 15. And then the next one is said is simplify. Now if you look properly at this question, you'll find that you can't simplify it further. Why? Because there is no number that can go between 8 and 15 without giving us a remainder. Thus, 8 and 15 is the final answer or the final result. Now to divide fractions on the other hand, you simply have to flip the numerator and denominator of one of the fractions. Now I usually use the fraction from the right hand side. I don't know about you. Just not to confuse myself. So what it means is that while you're flipping it or while you're changing the numerator and the denominator, the figures there, your sign will change because now you're changing things. So it's moving now from division angle to multiplication angle. What do I mean? Before we see further more on this, let me just show you. Let me use the same example we just worked on here. So if I have 2 over 3, in this case now divided by 4 over 5, what this is trying to tell me is I will changing this sign to multiplication because you can't work this way. You must change the sign. You can either change this group over here, flipping the numerator, the 2 will come down and the 3 will go up. Or you can change this group over here. Same thing, flipping the numerator and the denominator. But I love to use the one at the right side, like I said, at the right hand side, the far right. So I love to use this group over here. Because I believe this one is what you're using you're using this one to divide this one. So you work on this one. If this one is okay, the rest will be okay. So what do I mean? This becomes now 2 over 3 times, when I flip it, 5 over 4. I have now converted to our earlier on case where we talked about multiplication of fraction, if you look at that right now on the board, it's all about multiplication. And this function, this pattern, comes into play again. Numerator, multiply, numerator. Denominator, multiply, denominator. Now you can do it that way, and still simplify it down. Or if you look at the functions from the left and the right, and you see that both the numerator up against the denominator down of the both side, they have the same common multiple. You can actually break it down there, or you can divide it or simplify it there. But if you don't want to make much mistake, you can do as I'm about to show you right now before I use the second method. Now you can multiply as usual. 2 times 5 is 10 all over. 3 times 4 is 12. Now in this case, 10 and 12 have a common multiple. There is somebody that can divide both 10 and 12. And this person is called 2. Now 2 into 10 is 5. 2 into 12 is 6. Nothing again can divide these two functions. Thus, your answer becomes 5 over 6. Again, I say, you can use this method, or you can also choose to use another method I'm about to show you right now. I call that the straight up cancellation. You can just cancel straight away from your functions without the need of multiplying through and simplifying down. What do I mean? Say you have the exact same thing, this group over here. Now, you have 2 over 3 times 5 over 4. I know that if I cross-check, if I look from the denominator here to the numerator here, I find 3 and 5, and nobody can cancel or divide the both number. At least no LCM, no common multiple can function in that case scenario. But when I look this other angle, that's why you have your multiplication sign, because your multiplication sign is showing you a cross-checking. So this is going this way and this is going this way. So when I look this other angle, that's my own pattern, it's my own theory. So you're not going to see the theory anywhere, it's my own personal theory. So when I cross-check it this way, you're going to see 2 and you're going to see 4. 4 and 2 have a common multiple. And we can use 2 in this case. 2 here will give us 1. 2 here will give us 2. Then we can now find out that there is nothing again that can divide the both numbers. Thus, we multiply through. 1 times 5 is 5, and then 3 times 2 is 6. Now, if you look at it, both case, we have the same number. So, I always use this phrase. Mathematics have different, you can use different route, or you can use different road, or you can use different path. It has different road, it has different path, but they all lead to one destination. So no matter what method you want to use in mathematics, you must arrive at the same answer. That's how you know that you're not doing something that is faulty. So let's go on. Now we are given this case under the multiplying of fractions. They say half times 12 over 48. 1 over 2 times 12 over 48. Now, if you see the indication there, we have the numerator and we have the denominator. We multiply through. Now, follow those ideas now. Multiply, the first step, there's some guidelines to help you. The first step is to multiply the numerators of the fractions first. The numerator is the number on top. I'm sure you're quite familiar with this from the earlier classes we've had, or the sessions we've been having. The numerator is the number on top of the fraction, and the denominator is the number on the bottom, or at the bottom. The first step to multiplying fraction is to line them up so that their numerators and denominators are next to each other in this way. Numerators next to each other, or probably you want to make it even better, you can do it this way now. So while it is this way, you can just put an arrow and make it 2 times 5 all over 3 times 4. That's if I'm here to break it down. So 2 times 5 all over. Now you see that 2 over 3 and The numerator here 2 and the 5 over here have come to be together, and they are divided by the common denominators 3 and 4, side by side. So you make sure they are next to each other. If you're multiplying the fraction 1 over 2 by 12 over 48, then the first thing you want to do is multiply the numerators first. That's the first thing. First things first. 1 and 12. And 1 times 12 will give you 12. Write the product 12 in the numerator so it goes up in this way. And then multiply the denominators of the fraction. Now you will just have to do the same thing with the denominators. Multiply 2 and 48 to find the new denominator. 2 times 48. The product of 2 and 48 will give you 96. Write this answer in the denominator of the new fraction. Therefore, your new fraction is 12 over 96. But is the case over or is the game over? No. In this case, it is required of you, it is expedient of you that you break it down to the lowest form. Simplify it down to the lowest term. So you can break 12 down as well as break 96 down using their common multiple. Now, simplifying the fraction, you use this step. This is the final step. So we've talked about the first step, numerator, using the numerator or working with the numerators. The second step, working with the denominators. And then actualizing your new fractions. Then the third and final step is to simplify the results as low as it can be. That's if it can be done. But if it cannot be done, as in this case, where the other scenario when I showed you that 5 and 5 or so, two numbers that are not of the same common multiple or factors could not go with each other. So in that case, you leave it be. To simplify the fraction, you have to find the greatest common factor of both the numerator and the denominator. The GCF, or the greatest common factor, is the largest number that can be evenly divided with both numbers. So the largest number that can be evenly divided without any remainder is the number you use. In this case, it is 12. And 12, in this case, in the case of 12 and 96, it is 12. And 12 happens to be evenly divided, will be evenly divided with 96. So if you divide 12 by 12, you will get 1, and 96 by 12, you will get 8. Therefore, your new answer will become 1 over 8. So now you've reduced 12 over 96 to the lowest term, 1 over 8. In this case of 1 over 8, being brought down from 12 over 96, we also call the comparison between 1 over 8 and 12 over 96. We also term it a different fraction. That fraction is known as what we call the equivalent fraction. Hence the word equivalent tells us is equal. That's where the equal to comes in. So 12 over 96 equal to 1 over 8. Further information for you. If both numbers are even, you can also start by dividing them by 2. Like I said, play it safe. Don't just, that first rule you use, or the first method you use, which is where you look out for the GCF, the greatest common factor, is carried. But sometimes you might run into some issues of looking for the greatest common factor. We all know how HCF and LCM works, and sometimes the trick of it or the complexity of it tends to come to bear. So you must, in my own opinion, go with the simplified version, using 2, using the least of it, the lowest, to simplify your fraction. If you use 2, it's way easier. You'll go it step by step until you get to the final answer. Now, if you go step by step, you'll now see the order, the in-betweens, the other equivalent fractions that are in between 1 over 8 and 12 over 96. One of such is 6 over 48. Another is 3 over 24. These are all parts of the equivalent fraction. Then you may notice that 3 goes evenly into 24, and can divide both the numerator and denominator. So you can just break it down. What they're trying to tell you there is just to break it down. When you use 2 on the first scenario, you use 2 to divide 12, you get 6. 96, you get 48. And then you use 2 again, you get 2. And then you get, you get 3 and you get 24. And then you now use 3, you will get 1 and you get 8. Now, if you do the multiple of the first 2, you use in dividing. The second 2, you use in dividing. And the last 3, the 3 you use in dividing. The last number, which is the 3 you use in dividing, you will get 12. That's how you know your GCF is 12. Greatest common factor. Now, the second side of our teaching today is all about division of fractions, and we're talking about dividing fractions. Now, in dividing fraction, as earlier stated in the introduction, reverse the numerator and denominator of the second fraction. Now, specifically the second fraction. Initially, we said any of the fraction, but here there is a specificity on the second fraction. Change the second fraction position. Numerator goes down. That is, initial numerator goes to the denominator's place. The initial denominator goes to the numerator place. And then you change your sign from division to multiplication. Let's say you're working with similar question, or they are giving a fraction that said divide the fraction 1/2 by 18/20. Now you must first find the reciprocal of 18/20, which is, like, reciprocal there means the movement, the change of position, which is 20/18. Now reciprocal is something that is opposite each other, that is, you're opposing it. 20/8 is the reciprocal of 18/20. Now after you finish changing the position, change the division sign to multiplication. Now what that means is that you're giving 1/2 divided by 18/20. The logic there is telling you that forget about everybody here, you can cover up this, put your hand and cover this, and just change the position and make this one 20/18. 20/18. And then you come here, the next thing you do is to change this sign to multiplication, and then you put back your 1/2. The work is done. And then you can now apply the logic of the multiplication of fractions. What you did earlier on, you can apply that same logic again. Multiply the numerators and denominators of the fractions and simplify your answer. Now do the same thing you will do to multiply. If your numerator is 1/20, you get the result of 20 in the numerator. If you multiply the denominators 2 and 18, you get 36. In the numerator, you get 36 in the numerator. So you have the case where we used before earlier when we were multiplying, because 1/20, that is 20 times 1, will give you 20. 18 times 2, or 2 times 18, when you flip it around this way, 2 times 18 will give you 36, which is initially what we did. And the product of the fraction will become 20/36. Now you get to reduce it to the lowest possible form, which is 5/6. That's the lowest format you can get to that fraction. So, how about we'll do some practice on the following question. Multiply and then simplify the following fractions. Do this and then get familiar with what multiplication and division of fraction is all about. Now, I'm interested in doing one question for each, so you can be able to see how you can deal with it, especially for the one that has to do with mixed fraction. If you look over there, you will see in the number 3 and number 4 of each of the questions. Okay, number 3 and 4 of multiplication, you see there's a 4 that is staying apart from the 3/4. Now that 4 is a 4 whole number, 3/4 times 5/8. But I'm not interested in that one. I want to do the number 4 of that multiplication, which is the 4 whole number 3 over 4 times 2 whole number 5 over 8. Let's see what that question will give us. We are given 4 whole number 3 over 4 multiplied by 2 whole number 5 over 8. Now initially we've been learning everything about when it is both proper or improper fraction. But in this case, they're giving us a mixed fraction. How are we going to work this? How will it work for us? Now I'm going to try 2 ways by which it can work to see the similarities. Now one of the methods I'll do is the improper, pardon me, the improper method, the improper fraction method. Then the other way I'll do is the split it up method. Yes, it's related to how we did it when we handled our addition and subtraction of fraction as regard mixed fraction. Now in this case, I will start first with the improper fraction method. So in the improper fraction method means I have to move this whole thing to become improper fraction. Remember, improper fraction is the fraction where the numerator is greater than the denominator. So 4 times 4 is 16, and 16 plus 3 is 19 all over 4 times 8 times 2 will give us 16. 16 plus 5 will give us 21 over 8. Now in this case, I have broken this down to improper fraction. The numerators are all greater than the denominators here. We use our fraction method, what we just did initially. We do a multiplication method rather. Multiplication of fraction method, which we just did. So you multiply through 19 times 21. Let's do this together. We know that when we have 19 times 21, our answer will become 399. 399. So this is 399 all over 4 times 8. 4 times 8 will give us 32. So we've gotten our fraction up to 399 over 32. So in this case, it's still in the mode of mixed fraction. We have to bring it down to proper fraction. And to bring it down to proper fraction, sorry, it's still in the mode of improper fraction rather. We have to bring it down to proper fraction. And to bring it down to proper fraction means we have to make it a mixed fraction. So let's see how many of 32 can go into 399 and how much will be remaining. Because we know there will be remainder. Why? Because the end of the denominator is having an even number, while the end of the numerator is having an odd number. So the number is going to end in odd. So let's see what will happen when we do this. So let's try 32 times 11 to see how much we're going to get from this. 5, 3. So can any other 32 go here to give us what we are looking for? Yes, the next 32, which is the 12th one, will give us 384. So it will go 12 times, means this will become 12 whole number. 12 whole number. If it's 384, how many will be remaining? If our mathematics is correct, it will be 15 remaining. 15 over 32. Now let's see if we are correct with this answer when we use the second method, which is the split up method. Now we have 4 and 2, so we can take them aside, keep them aside. These are the whole numbers. Now let's work on the on the fraction numbers. So we have 3 over 4 and 4 over 8. Now if we use this way, let's see if it's going to be correct. If it's not correct, means we're not going to be using this method again. So 3 times this will be 15, and this times this will be 32. So we're having 32 here, but on top of my head, I think it's not going to give us the exact same thing. Albeit we got the same fraction, but our whole number is not going to be the same. 4 times 2 is 8. Therefore, we're having 8 whole number, 15 over 32. Different answer. Why is that? That means we might have gotten a mistake somewhere. So for us to analyze our result to see where we had a mistake. So let's come back to our initial problem here. We had 21 times 19. So let's see one more time if we were right. 1, 2. So yes, we were right. We must have been having a problem somewhere. 339 divided by 32. We know that times 10 will be 320. Times 11 will be 352 times 12. So please, for the safer, to be safe, for the safer means, we can use this method and negate this other method, just to be safe. So that's for this one right now, for the multiplication angle. How about the division angle? We will attempt the question number 4. Question number 4 in the division angle has to do with 2 whole number. Or rather, let's attempt the question number 3. It has to do with double mixed fractions. So let's see, 12 whole number, 1 over 2 divided by 3 whole number, 1 over 2. Now we're having 2 mixed fractions here, and they say divide. Again, as in the case with our multiplication, when we did our multiplication for the mixed fraction, change to improper fraction. So 2 times 12 will be 24, plus 1, 25 over 2 divided by 2. 3 times 2 is 6, plus 1, 7. 7 over 2. So we're having 7 over 2, 25 over 2 divided by 7 over 2. Our logic earlier on said when we have division in fraction, we choose a particular fraction, which I actually encourage to be the right hand or the extreme. The right extreme fraction, the one at the right. You change the position now, it becomes 25 over 2 times. Now your sign changes, and these guys will change their positions. 2 over 7. Now if you look very well, 25 and 7 have nothing in common. But 2 and 2 have something in common. 2 divided by 2 will be 1. 2 divided by 2 will be 1. Therefore your answer will become 25 over 7. You break it down to the lowest. 25 divided by 7 will go 3 times. Because 3 times 7 will give us 21. Thus, it will go 3 times, and then it will remain to get 21 to 25, you need 4 more. So it will remain 4 over 7. This is our final answer. So to conclude for today, let's get some question from our exam guide to see questions that have to do with multiplication and division of fraction. Now in 2019, they asked a question that is related to time telling. Howbeit, you have to do some multiplication speed too to understand the answer. They say how many seconds make up 3 whole number 1 over 2 minutes. 3 whole number 1 over 2 minutes in the actual words will be 3.5 minutes. So how many seconds are there? So let's solve that problem quickly and answer that question. So we have 3 whole number 1 over 2 minutes in words or in pronunciation will become 3.5 minutes. So we're looking for 3.5 minutes. How many seconds will make it? So before then, we know that in conversion, 60 seconds makes what? 1 minute. That means if we split it up as I usually do. So if you split it up, it becomes 3 minutes and half minutes. So if you're having 3 minutes, you just do your normal arithmetic because 60 seconds equal to 1 minute. Therefore, for 3 minutes, 3 minutes will become 60 times 3. And 60 times 3 here will give you 180 seconds, rather. So for 3 minutes, we have 120 seconds. But we're not done yet. We still have the problem with the fraction here. The 1/2 minutes, the half minute, half a minute rather. So we know half is anything that is twice as low as 1. You're having 1. Sometimes twice as low as 1 is half. So now we know that 60 seconds make 1 minute. So if this is 1 minute, something that's twice as low as 1 minute will become twice as low as 60 seconds. So 60 seconds now, we know 60 seconds make 1 minute, so it will be twice as low as 60 seconds. Means we have to do 60 seconds times 1/2, which is the half. And if you do this math very well, this is like saying 60/1. Now we're down to our multiplication of fraction. If you look carefully, 60 times 1, 60. 1 times 2, 2. And then we can divide down. 2 into 2 is 1. 2 into 6 here is 3. And 2 into 0 is 0. Therefore, our answer becomes 30 seconds. Putting that together, our total answer will become 180 seconds plus added with 30 seconds. And then our final answer will become 210 seconds. So the answer in that here is option number B. So that was our answer for that here. Now, looking for yet another question, but this one is a bit intriguing because it's not directly connected to multiplication or division, but somehow it has to do with fraction. So it got me interested again. In our year 2013, we got to see a question that talks about 3:2 is expressed in the form of P:4. They say find the value of P. Now we are taking a further step in this particular aspect, albeit we are still going to touch on that particular topic because what this is talking about is direct proportion. But we are going to talk about proportion later when we are talking about ratio and proportion. Now, 3/2, so 3:2 is same as 3/2. Sorry, let me just write this on. So we have 3:2 going to P:4. And they say find the value of P. What you just do here is cross multiply. We call it cross multiply. Like I said, if you look at the cross multiply symbol here, it's a multiplication symbol. It's like a time. So it hence why it's called cross multiply. And when you cross multiply, it becomes 2P here, or 2 times P equal to 4 times 3. When you do this now, it becomes 2P equal to 12. P is equal to 12. You take your 2 over. When multiplication is going over an equal to sign, again, the sign changes. The sign of the multiplication will change to a division. When division is going over an equal to sign, the sign of the division will change to a multiplication. When addition is going over an equal to sign, the sign of the addition changes to a subtraction. When the subtraction is going over the equal to sign, the sign of the subtraction changes to addition. In this case, it becomes 12 divided by 2, which gives us the answer 6. So P is 6. And if you want to just to understand why is P 6. Now, if you look carefully, you must have, in sense of proportion, that's what I call it proportion, everything must be balanced. So you must have an equivalent, hence the equal to there, hence this equal to here. You must have equivalent between the left-hand side and the right-hand side. So if you have 3 over 2, the other number over there must be equivalent to 3 over 2. In this case, let's do some proofing and see. Now let's come back to this, our initial equation that was given to us, or the statement that was given to us here. Now they say 3 over 2 equal to, now we know that P is 6. 6 over 4. If you look carefully, you can use 2 to divide these two fellows over here. 2 into 4, 2. 2 into 6, 3. You cannot break down any further. Now this 3 over 2 is equal to 3 over 2 over here. Hence it's balanced. So this is your proof that this answer, or the P equal to 6, is correct. If you look carefully again, 3 over 2, the rising series, or 3 over 2, the next in the series will become 6 over 4, going upward that way. Hence why we call it equivalent fraction. So I believe that with all we've done today, you have gained and gleaned a lot of knowledge that have to do with multiplication and division of fraction. Till next time, take care. Bye.